and beans and all kinds of fun stuff.
Yeah. So just click unmute on this.
Yeah, there you go.
All right. Can you guys hear me okay? They've got a lot of microphones up here. It's going to make me a little bit nervous. I don't think I've ever had this many people listening. So as he said, I'm Elizabeth. I'm really excited to be here. I'm from Southern Ohio, so I don't have to try to hide my tweak of an accent down here, whereas when I go north, I tend to get teased a little bit for talking too Southern. So I'm really excited to just let my real self show today. So I wanted to really go through just a handful of topics I think that might be something to keep on the forefront of your mind as we move into 2020. David is passing out our on-farm research books. If we run out, there's more in my truck, and we'll go grab those for you. A lot of the things I talk about are in there if you want to learn more in detail, and then there's all sorts of things beyond what I'm going to talk about. You know, it's good reading material. If you want to fall asleep, you're struggling, keep it next to your bed. Look at the pictures when you want to stay awake, and look at the words when you're ready for a nap. So I want to start off, one of the things that we did in Ohio this year, I know you guys weren't quite as wet as we were in Ohio, but we received really intense rainfalls in the early months of 2019. And that really changed the way that agriculture in Ohio looked. And so up here, that's one of my research plots on the left. We planted it. We finally got around to getting that planted. I think June 8th was the day that field was planted. It was coming up. We finally felt like things were turning around. And then we got a 4-inch rain. And the problem with 2019 was we kept getting rains like that. It was backed up. It seemed like tile wasn't working, but it really was. There was just nowhere beyond the tile for the water to go. So it sat underwater like that for about 10 days. That was a bad day driving by every time watching it. The map on the left here, that really is the weather information that really I think best tells the story of what happened to us. Dark green, this map shows, let me walk through it here. It shows the amount of rainfall above normal in the months of April and May in 2019. And I can find the pointer here. So I live right about there. Where I live, we received about 5 inches more than what we normally receive in those 2 months. And I mean, 5 inches is about what we get that time of year typically. If you went a little further north, they actually received about 12 inches more in those 2 months. So we had really what was looking to be quite the disaster in Ohio once we were reaching June. And so we can really see this in our data. This is the Ohio corn planting progress data that USDA puts out weekly that time of year. 2019 is that red dotted line. And this is from the years 1979 all the way up until last year. So you can see that on the corn side, we had unprecedented corn planting delays. Really the latest we had ever gone before was really that third week of June, and we had corn planting dates that extended clear into July in Ohio. Very similar. We've had late planted soybean years before, but again, nothing like 2019. And so going into last year, into the season, we did have 1.5 million acres in Ohio that went unplanted, mostly in northwest Ohio, but some in Claremont County. I think Claremont County was the highest number of prevent planted acres in southwest Ohio. So I could see on that map that you guys were a little wet maybe in the northern part of Kentucky, but I know you guys seemed like you were having a better time of it than us for most of the spring, but some of you perhaps struggled as well. So what we did, halfway through the summer, we decided that we really had this unprecedented opportunity to collect information about what happens when we wait to plant corn and soybean until much later than we have in the past. So we put out a survey to farmers across Ohio, asking them information about where their fields were located, and then we wanted to capture yield, test weight, moisture, and then some other information about what they planted in that field to help us understand what we were seeing happening with yields with those late planted dates. We ended up getting about 500 fields entered into the system, so that was pretty exciting. It was about half corn and half soybean, and they represented 51 counties in Ohio. So I've had a fun time. These were turned in early January, so I've had a fun time kind of digging through this data. And so I'm going to break it down a little bit for you here. From our survey results, across the entire state, we saw about an average yield of 175 bushel per acre, which was quite a bit higher than what we were really expecting when we were talking about this in July. To compare, we might have a bit in our survey of bias on the high side. The last USDA report for state average yield is 164. So hopefully that just means that the guys that submitted in data to the survey were just giving us their best fields because they didn't want to admit, the worst of the worst. I know I sure didn't. We saw a range. I mean, it got pretty bad. Our lowest yielding field that was entered was 56 bushel an acre, which was lower than most of the bean fields that were entered on the corn side. But in some parts of the state, the yield potential was still very good. I was pretty surprised. You're gonna see this come through. I was really surprised by how normal the crop ended up being, despite the delays that we faced. The average planting date that was reported was May 30th, which was about 15 days later than what typical 50% planted in Ohio is. And then this is what all those yield data points look if you graph it by planting date. So we've got the date that field is planted here along the bottom, and then the yield that was achieved for that site. The points are colored by crop reporting district in Ohio. We had 7 of our 9 crop reporting districts were represented in the survey. You can definitely see West Central Ohio and Northwest Ohio, so the yellow and the red dots. That was where we had the most rainfall. It was the 4th wettest spring on record in Northwest Ohio, and it was the 7th wettest spring in West Central Ohio. And you can see that there really was it wasn't really until right there at the end of May, early June, that those guys even really got a chance to get into the field, other than this one guy who was really pushing it for some reason clear up the 2nd week of April. Same thing with the soybean results. Really, they were probably more normal. We, again, are slightly higher on the average that we saw in the survey from what USDA is predicting, but only by a handful of bushels, so we're not too far off. We were actually 19 days later than normal with our average date on this survey compared to what USDA has reported for the past 3 years. And yeah, this is what a lot of our fields look like once all the water disappeared. So this is that same data. This is actually probably my favorite graph from the whole thing. You guys are seeing what a nerd I can become up here. Because of the length of time on the planting dates, how far we went from the beginning to the last planting date, those points are more compressed on the soybean graph. So you can really see those planting windows open up on soybeans. So you can see everybody runs for a couple days, we get rain again, nobody moves, and then we run for a couple days. And I honestly think this is the most interesting thing we could see. If you line it up on the same graph with the corn, the windows were exactly the same. So if nothing else, we learned from this that we were all in the same boat together, and we definitely needed a boat in spring 2019. And so I think that this gives us hope, because this is a trend we keep seeing repeatedly. Already again this year, we have received more rain where I live than we did last winter. And luckily, I think now we at least know that we don't need to panic yet. Even when we plant late, that yield potential, although the risk of losing yield is going to be higher, there still is an opportunity, as long as things come together the rest of the season, to get high yield. And so that's really what we can take away from this. Probably our biggest saving grace was we did have an unusually late frost in Ohio. Normally early October we start getting a little nervous. We didn't see our first frost until it was right before Halloween. So we did get that extra time at the end of the season to make up for what we lost at the beginning. The biggest concern, I guess, was really part of the state really got dry. Where I live, we went from having more rain than we knew what to do with to not receiving anything more than 1/4 of an inch from the last of June all the way to the middle of September. So we were facing what I would consider drought conditions, but luckily our yields ended up pulling through for most folks. So that's all I'm going to say about the yield survey. Hopefully we never have to deal with that again. It seems like, I know it's easy to say yields were good, but when you really think about the fact that we had 1.5 million acres that remained unplanted across Ohio, that really drives home the impact of the weather conditions we faced. So now I'm ready to turn around and look forward to 2020, and I've picked out a few topics that I think should be something we should be looking towards and thinking about as we prepare for 2020. And the first, when I talk to folks, this is one of the biggest concerns I've heard. We had a very wet harvest in 2018. We had a very wet spring and summer in 2019. And the concern about soil compaction, I think, has really grown as a result of that. And so what is soil compaction? Soil compaction is really just when we're compressing that soil, we're removing the space available in those. We worry a lot about maybe the top 12 inches of the soil. We're compressing, taking away that space for water and air in the soil, and that's going to impact the ability for our plants to really grow and thrive in those soils. When we think about compaction at this level, our heavy equipment is really one of the primary drivers of that compaction, especially when we're taking that heavy compaction into fields that are a little higher soil moisture than what we really should be. So I'm going to walk through an example, and this is one of those, if you've gotten the book already, you can kind of follow along. There are some pinch-row compaction studies in there if you're curious. But I'm going to use pinch-row compaction as an example. And so, our planters today, especially these central fill planters, have gotten very heavy. And we're carrying the majority of that weight here over these tires in the center of the planter. And so this gives us the ability to do a field trial where we can look at the difference in yields between crops that are grown in these pinch rows, which is where those tires are having the most weight exerted, compared to the wing rows. And so we've run some tests to compare those two to see what the yield effect is of compaction in these fields. And so another factor that we've added into this trial, because it's a question we get a lot, is do we see a difference on these central fill planters when we look at planters on tracks versus planters on traditional wheels? And so here, this is, I think, a nice picture because you can kind of see the thought process behind that track system being better for compaction is that you're spreading that weight out a little bit more. And you can see here that the tracks that the tracks are leaving are a little wider, a little flat, and less of that typical U shape that you're going to see from the tire. And so it's just like the elephant versus the girl in high heels who has more pressure on the ground. And you're surprised to find out that it's the little girl, right? But it's that surface area that's the secret. And so that's what they're trying to drive home with the tracks. So I've got some little anecdotal pictures here. So this is in a field where we ran that study. We went into the rows with tracks versus the rows with wheels. And you can see anecdotally the difference in the way that root is able to take advantage of the soil space. In the tracked area, there is less compaction. You're seeing that root be able to expand and explore more of that soil area, whereas in that row next to where the wheels ran, you can see there's that sidewall compaction. That root is being blocked and not able to expand. And presumably you would expect that not having a strong root system would cause problems down the road. And we do see that in a lot of cases. In most of our studies, we see a 10 to 20% reduction in yield in those pinch rows compared to the wing rows. In some years, if it's not very wet, we don't really see that big of a difference, but in the years where it matters, say 2019 for example, where you're already pushing into marginal fields, these tracks versus tires can make a big difference. Here you can see, this was from a field in central Ohio, if you're familiar with Farm Science Review. This field was right next door to there. And we pulled ears from the pinch rows and the wing rows, and you can see right there between those ears that there is a very big difference. And I wasn't cherry picking. I just walked down the row and I grabbed every other ear until I had, is there 5 or 6 there? So I just walked out till I knew I was in about 20 or 30 feet and just picked ears, didn't look at them. Really, and then the next thing you think about when we're talking about compaction, we talk a lot about that surface level compaction. That's what we worry about when we're seeing ruts. It's what we're trying to fix when we're going out with tillage. But when we talk about the amount of weight that we're putting on some of our fields, I think we really need to worry more about the deep compaction. It's something that you're not going to see.
Was this conventional tillage?
Yes. And yeah, he asked in case you didn't hear if it was conventional tillage. And the answer was yes. That deep compaction is going to be harder to see. It's harder to measure. And it's something that probably is actually taking our yields down. We talk about invisible yield robbers, and I think deep compaction is one of those. And it's going to be nearly impossible to mitigate except for taking time and letting nature run its course with that deeper compaction, because we don't have tillage tools that can get down and take care of those. So going into 2020, some of the tips I have for trying to reduce your compaction is really to avoid field operations as much as you can when fields are too wet. I know it's tempting. We got to a point where it was go or not get to go at all, and we did like everyone else did, and we went ahead and pushed. And so that decision sometimes is taken out of your hands. But when you do still have that decision, this is something I think is important to keep in the back of your mind. Finding ways to reduce your field traffic, whether that's controlled traffic with your grain carts to minimize the amount of field space that you're driving over. That's always, I think, a pretty good idea. If it's really wet, maybe, I know this is not going to be a popular thought for anybody, but reducing the amount of weight that you're putting on your planter, maybe only half fill. It's going to take more time to fill, but long term you might be gaining yield and not having that detrimental effect on your field. Really the easiest one that is going to give you the biggest bang for your buck is making sure that your tires are inflated properly and that your tractors are properly ballasted. How many of you guys have ever checked the tire pressure on your tractors and made sure, and your implements, to make sure that they're within the recommended range? A good number of you. I think most of you are aware that the ideal tire pressure for road travel is very different than for field operations. And if you're, I know that this is another thing, hopefully down the road technology is going to improve and give us the ability to better adjust our tire pressures, because really I think a lot of us maybe are trying to run somewhere in that middle, so you're not really at the ideal road pressures, you're not at the ideal field pressures, and it's really a lose-lose situation when we're talking about compaction and then safety on the roads. But you know, we have a grad student who we recently did an indoor field day in January looking at tire inflation pressures, and we asked him to take one half of the tractor down from road inflation and the other half down to field inflation. And he thought, I think, letting the air out of the tires was going to take him a minute or two. When he was still on the first tire, about 30 minutes later, you know, I said, hey, do you think maybe you want to start letting the air out of all of the tires? Otherwise, we'll be here till 10 o'clock tonight. So that's something I think we don't really think about. It takes longer than you expect to let air out of tires, and it definitely takes longer than you expect to air them back up. But this is something hopefully down the line technology will help us solve that issue. So I'm going to move on to the next thing I wanted to talk about, and that's Frogeye leaf spot. This is one you guys, I think, have been dealing with it probably more consistently than we do in Ohio. How many of you guys have dealt with Frogeye in your fields? Is anybody looking for Frogeye in your fields? I suspect most of you have it and just haven't recognized it yet. It does have a very characteristic signature look about it. It's called Frogeye. It looks just like a frogeye. You can see it here on these leaves. So it's a small dark spot, and then it's going to have that reddish purple margin, and then it's going to be gray or brown, so it looks like an eyeball with those two different colors. Not only is it going to be the leaf that's affected, but if that disease progresses and becomes quite severe, you can see symptoms on the stems, you can see symptoms on the pods. And in 2018, did many of you have some brown or purpley colored wrinkled up seeds? I think we attributed a lot of that to stink bug, but I do think we were seeing some frogeye because of the severity in our fields that was affecting our seed quality as well. You're going to see it first. It's going to develop on those young leaves, so you're going to see it in the top of the canopy first. The problem is it's spread really readily by warm, moist conditions. It especially likes rainfall, and it moves up from the south typically. I'm not going to lie, when I give talks about this in Ohio, I blame you guys. It comes up from Kentucky. You guys see it first, and those first couple hurricanes we get in late summer, usually in August or September, that brings it right up in the wind and water from you guys. So I'm sorry about that. So we do recommend that you start scouting typically in July or August for this disease. For you guys, it's probably a little bit earlier than that. This is a slide I use in Ohio, but I think it's going to apply to you. So in Ohio, we really see right along I-70 a very consistent dividing line where we see frogeye pretty much every single year down in southern Ohio, and we don't. It's pretty hit or miss in northern Ohio. So I'm going to, you guys to me are just an extension of southern Ohio. It's something you're going to see pretty perennially if you're not seeing it every year already. It can overwinter, and so it's overwintering in the residue in your field. Do we have any continuous soybean guys in here? A few, I see some head nods. It's pretty common in a lot of the southern counties I work in as well. If you've got reduced tillage, those are the fields that you should really be prioritizing scouting, because odds are that you have the disease in the residue in your field, and as soon as the conditions are favorable, it can infect the plants that are in your field. So we've got some fungicide trials that we've been running. If you want to check them out in the book, If you want to look at any of these pictures up close, they're on pages 40 or page 104, the fungicide trials. But I'm going to talk about the ones that we specifically were looking at, Frogeye. And so the first two I'm going to talk about were actually from 2018 when the disease was very severe in our neck of the woods. This was a field in Fayette County, which is probably about 2 hours north of here. We identified the disease in late July. It was at the threshold. The threshold for Frogeye is very low. They say 1 to 2 lesions per 25 feet of row, which at that point it can be quite difficult to scout and find. But we were well above that. We were seeing 2 to 3 lesions per leaf when we scouted on July 27th. We were really close to the cutoff for spraying. R3 is the cutoff for spraying and still being effective. We made that application just a few days after that, right at that threshold. Came back September 13th and scouted again. And so in this picture, you can see the leaf on the left was from a plot that was treated with fungicide. And the leaf on the right is from a plot that was not treated. So you can definitely see that that disease continued to progress in 2018, but the fungicide did appear to hold it back to some degree. And so this is what that report layout looks like. I'm going to zoom into the yield results here. So when we looked at those, the average disease progression or disease severity on the treated plots was 10% leaf area, which you just saw, and then untreated was 26% of the leaf area, which is incredibly severe. We did see a significant yield response, and that yield response of 5 bushel was enough to pay back the cost of the product in this particular case. What was interesting was we actually did a similar trial on a field that was the same variety. It was just across the road, exact same thing, but we did not see a yield difference between those plots. It was 3 bushel, not enough to statistically say it was different. And this did not cover the cost, that 3 bushel, even if we could deem it repeatable. It was not enough to cover the cost of that fungicide application. So this is kind of what we're wrestling with, when the disease is present and you make that application and you have that cost put into it and then you don't see enough of a yield response, what went wrong? How could we have avoided that? In this case, a lot of that I attribute to it being so close to the cutoff for effectiveness. Maybe this field, we didn't see it there, maybe this field was slightly further along in growth stage and made that fungicide not effective. But, we can't say that with any kind of certainty. The other situation with 2018, it was quite possibly the worst Frogeye year that we've seen perhaps ever. Our pathologist in Ohio said it was the second year in her entire career, which is over 30 years, where she had seen a need to have a 2-pass application of fungicide that would pay back. So perhaps in this case, we did need a second pass for fungicide to really protect our yield potential in those fields. So same situation, same layout, but in 2019 and in Highland County, so a little bit closer to you guys. We went out, the field looked great. We did detect Frogeye at threshold on August 5th, so a little bit later than last year. And in this field, we did see a significant response, and this was enough to pay back. In this case, that 3 bushel was enough to pay back the product. He had gotten a little bit better pricing on that. So this is one of those situations, when we look at the trials from north of 70, we almost never see a yield response that pays back that fungicide. But I would feel pretty confident down here, if you're seeing the disease and you're seeing it at threshold, that there's a pretty good chance that you'll see that yield response. The reason that I have Frogeye in this discussion, more weather, I'm by no means a weather professional, but I do get excited to see how things play out. And so I pulled this weather data yesterday from the weather station in Augusta, so just next door. And the first thing we pulled here is the average minimum temperature since December. And you can see we're quite a bit warmer than average here. And Frogeye, in order to not overwinter, needs quite a few days below 17 degrees. Any days we get below 17 degrees is going to help knock back the inoculum that we have in that residue. This is from the 1st of December until yesterday. This black line is 17 degrees, and so far we have had exactly 0 days that have reached 17 degrees or lower. So this is one of those, if we don't get cold here in the near future, Frogeye might be coming on earlier than we expect this year. You might want to start scouting earlier, maybe even lock in some pricing, some good pricing on fungicide now. But you know, it's weather, so it can change in 10 minutes. I've got a few minutes. I think one of the more exciting things that we've learned through the on-farm research program, which I'll give a couple more details about here in a moment, is the ability for us to look at these different trial protocols over a lot of different farms. And one where we've seen the most uptake for has been our seeding rate trials. So this is the soybean seeding rate trial. We've now had, over the last 3 years, 40 seeding rate trials across the state of Ohio. And our seeding rates have ranged from 50,000 seeds per acre all the way up to 240 seeds per acre. So if you told me you were planting 50,000 seeds per acre, I would think maybe you were planting corn and you were just a little bit out of your mind. When I find out your beans, I get a little bit scared. But we've got some very brave farmers that are willing to push the limits of what's possible in the field to help us all learn. With soybean, you know, the reason we have that flexibility to play with seeding rate is because beans are incredibly cool when it comes to how they respond to plant density. And so you can see here, this is a plant that was planted at 80,000 seeds per acre, and this one was at that's opposite. This one's 80,000, and this one was 160,000. And you can see the plant architecture difference, how when that plant has the space, it really bushes out and takes advantage of it. And so somewhere between here, you know, is there a sweet spot for what's the right seeding rate? The problem when we talk about beans is it's not really as straightforward as you plant this many seeds and you get this much yield. How well that plant is going to come up and how well that stand is going to be established is really what we're learning, what we sort of already knew, is the key to what the right seeding rate is. In fact, when we look at the yield data, we're going to see that there's really no connection at all between seeding rate and yield. That connection is between emergence and yield. And so we definitely go out for all these fields, do stand counts. We try to do stand counts twice, once pretty soon after planting and then again later in the season to see, one, how well those plants are coming up, and then two, how well they survive over the course of the season. Because I think all of you would be shocked if you went out to your fields right before you harvested and counted the number of beans you have out there. I guarantee it's a lot fewer than you think, because soybeans, they do like their space and they start elbowing their neighbors out of the way at some point in the season. We do have a project trying to understand when that point is and understand how they decide if they're going to murder their neighbors or not. We've had a wide range of stand establishment success across these trials. This year was the worst, 2019. We had a field that only had 50% emergence on average, which is somewhat terrible, especially if you only planted 80,000 and then you only have 40,000. It looks pretty terrible. But, you know, beans, this is something we've seen an improvement in the genetics and the ability to keep that seed. If you would have told me even 10 years ago that you would have 98% emergence on soybean, I like the last couple guys would have probably laughed at you. But it's definitely possible. We see it fairly consistently. Over 90% isn't rare at all for our soybean survival anymore. So this is what that yield looks like. This is a relative yield graph. So what I did was I took the highest yielding plot for each location, and I normalized all the other yields to that. So the 1 means that was the highest yielding plot within that location, and then we can look at, as the seeding rate changes, what the yield loss was as a result of that seeding rate. And this scale, some of these look pretty bad, but this scale is a little deceiving. It starts at 70%. So I'm going to throw a line up here at 90%. And so if we think about our typical state average, it's about 50 bushel per acre. Anything that fell below that line is only a loss of usually a little bit more than 5 bushel. This one down here was a few more. I will tell you that this orange plot, this is from 2018 data, that orange plot is the one that only had 60% emergence. You can see that losing 5 bushel or more as a result of changing your seeding rate in soybean is incredibly rare, at least from what we've seen in our on-farm trials. In fact, if we look at that 90% threshold in 2019, which I think was as bad as it gets in a lot of cases, we only had 7 sites out of 122 that lost more than 5 bushel, and you can see that trend is pretty similar. Even if we tighten it up a little bit and go to 2.5 bushel at the 95%, you still have a very low risk, is what we're seeing, of losing that level of yield just because of seeding rate. Typically, if it's more than that, there is another factor that we can bring in there to help understand. The take-home point on this is soybean seed is not cheap anymore. And so even if you're not willing, we'll jump back here real quick. Even if you're not willing, this is the 120 line. And other than, I'm going to try to justify the financial example I'm going to give here. Other than the location that only had 60% emergence, none of the locations lost more than 5 bushel at all when we stayed above the 120,000 seeds per acre, which is what the current university recommendation is, pretty closely. They want you to have at least 100 to 120,000 plants per acre at harvest. Pretty safely, we see that in our data, that the risk of yield loss is almost non-existent when you stay above that threshold. It's very safe. It's actually not that much of a loss even if you go lower than that. It's all over the place. There are no double crops. They are all full season. The maturities, you can look in the report. The 2018 report is available online if you want to look back and see. The cropping practice was different. There are some drilled, some 15-inch beans. There are some differences masked inside of here, but you can look at each individual report if you're curious about those. So the case I'm going to make is if you're sitting at a farm average of 160 seeds per acre, this is a calculator that you can go and run these numbers for yourself if you want to download our Excel calculator here at this website. But your return to seed cost at the state average of 50 bushel per acre, if you're seeding 160,000, is $361 per acre approximately. If you're brave and you want to go down to 120, which I'm standing here today telling you that unless you have a case in your field where you're concerned about emergence and survival, I would feel pretty confident with that 40,000 seed drop. Your return to seed cost is going to increase to $378 above seed. Doesn't take into account everything else you put out there. So just using this example, and this is Ohio, apologies, I didn't look up the numbers for Kentucky, but just extrapolating that out, our seed cost saving, just dropping that 40,000 seeds per acre, is about $17 per acre, and that's a lot of seed that, in Ohio, and a lot of money that we might not necessarily need to be using. Again, I'm not saying at all that I think that you should just make that snap decision to drop your seeding rate. I am going to say that I think that if putting more money in your pocket is something that interests you a little bit, that on-farm research is a great way to test the waters. And so I want to talk with my last 4 minutes about our on-farm research program in Ohio. Hopefully you're going to take the report home with you and check it out. But our goal here is to connect with farmers and help drive ag forward through on-farm research. And so we've partnered with farmers across Ohio to develop the protocols for the trials that you see in that report. I work with guys. We find out what the question is that they want to answer. We put together a way that we can go to the field, execute a trial with the equipment that they've got on the farm, and try to answer that question together. We've done everything from nitrogen rate to, you've seen the compaction research. Seeding rate's always popular. Even some off-the-wall things. I know you guys don't deal with them down here, but we had a trial last year trying to help control voles using cover crops. If you haven't seen a vole, it is a monster. They make soybeans disappear. I'm not joking. The first time I saw a vole attack, I thought it was a lightning strike. They will take everything in quite a large area and just eat it. So there's a trial in there, probably not something that you guys will ever have to deal with down here, hopefully, but interesting nonetheless. So no question is too odd or too difficult for us to try to answer. We want to make sure that we're catering to you guys and what you need to know to improve your farm operations. The protocols are standardized. They're pretty straightforward. Everything's going to be replicated. Everything is going to be randomized so that we can get that statistically significant response if it's out there. This really just helps us understand if when we see a yield difference, if that's something that we feel confident is repeatable in the future. You can check those out. We've been doing this since 2017 in Ohio. We started out with 39 trials in 13 counties. In 2019, we still had, despite everything, 88 trials in 30 counties. When the season started, we had 152 trials planned. So we lost some, but we gained some back as the season went on. And if you're interested in the past reports, that's the website where you can download it. And I will stop there and take any questions.
Your on-farm trials are replicated within a farm, and then are they replicated on all?
It depends on the trial. Most of them are replicated over farm. Some are only at one farm, but they are all replicated within the field.
So you're getting publishable data out of this.
Yes. Yep. Yeah, I'll have to bring you a copy of the report. You don't have one.
I think there's some that still need a book.
Okay, I'll grab another box out of my truck.
Relatively speaking, between drilling 15-inch rows, 30-inch rows, I've done 30-inch rows. What? I've done well with times with 30-inch rows.
Yeah, I mean, I think in most cases we've seen it's usually a toss-up between drilled and row beans of the 15-inch rows. Typically, and I mean, maybe down here it's a little different because you might get to canopy quicker. We normally see a yield loss with the 30-inch beans because they're not going to canopy as quickly. But it's normally a toss-up unless, yeah, yep. As long as the drill's set right. If you're leaving them, yeah, you know what I mean. Yes. So we haven't seen any big differences between those two.
Any more questions?
You can follow us on social media if you're into that sort of thing. But thank you guys.
If you guys are looking for a book, she's going to run to the truck and grab another box of books.